Hi everyone, my name is Nick, and today I'm going to be talking about live streaming. Now, when you think of live streaming, you might think of services like Netflix, Spotify, or Twitch, and you'd be right to do so because these are all streaming services. However, in this presentation, I want to primarily focus on live video streaming, so services like Twitch and YouTube Live, which differ from services such as Netflix and Spotify for a number of reasons. The main one being that media being streamed is already pre-established in services like Netflix and Spotify, whereas in video live streaming, the media is real-time, much like live television. That being said, the technical definition for video live streaming is that it is the delivery of media in real time over the internet, much as live television broadcasts its contents over the airwaves via television signal. Now, before I go any further, I want to establish some terminology. I will be referring to video live streaming as simply streaming, and the client or broadcaster as simply the streamer, just to make things a little less confusing. So, what exactly is going on when you tune in to Twitch or YouTube Live and see a streamer streaming? Well, the general process is that the streamer sends a video feed through the open internet into the streaming service's servers using the real-time messaging protocol abbreviated as RTMP. Once in the service's servers, the video feed is authorized and prepared for viewing. This means that the streamer is responsible for sending the video stream to a streaming service for processing through a software or hardware video encoder. This is most commonly done through a live streaming software such as Open Broadcast Software, abbreviated as OBS, or XSplit. The service provider is responsible for accepting the RTMP video feed from the streamers into its ingest servers, which authorize and register the video feed, then transport it into their transcoding systems, which are typically found on separate servers. From there, the RTMP video feed is transcoded into multiple HTTP live streaming protocol feeds, abbreviated HLS feeds, that are distributed to several points of presence servers, abbreviated POP servers, and presented to the viewers on their site from a POP server based on their geographical location, meaning the one with the lowest latency. As I mentioned earlier in the video, streaming software, such as OBS, is commonly used by streamers to encode their video feeds and transport it to the streaming service of their choice. Now, there are a few key components that OBS needs in order to get up and running. First of all, the streamer must decide what bitrate they wish to stream at. The bitrate, or the rate at which bits are transferred from one location to another, is one of the main factors which determines the video and audio quality of the stream, and is limited by both internet speed and bandwidth. So, the optimal bitrate for a streamer is that which is large enough to look and sound good, but small enough to work within the means of their internet. For example, if you have really good internet, then you can stream at really high bitrate. If your internet is not so good, you probably want to stay at a much lower bitrate. From there, the streamer must decide which of the two main types of bitrates they would like to stream using: variable bitrate, abbreviated VBR, or constant bitrate, abbreviated CBR. The difference between these two types of bitrate is that VBR varies the amount of output data per time period based on an upper limit which you set within the software, whereas CBR doesn't vary the amount of output data per time period. It will maintain a constant bitrate, hence the name constant and variable bitrates. In the end though, this decision is not a very hard one. This is because VBR performs poorly for video over open internet, so it is usually recommended for streamers to use CBR. Similarly, there is another type of bitrate that is typically handled by the streaming service called adaptive bitrate streaming, abbreviated as ABS. ABS allows streams to have quality settings of lowering bitrates to accommodate those with varying internet speeds and bandwidth. So, for example, let's say a streamer is sending a video feed to a streaming service at a constant bitrate of 2500 kilobytes per second. The streaming service would then use ABS and distribute that stream to its end users in varying levels of quality. Perhaps you have 2500 as the source quality 2000 as a medium quality, and 1500 as a low quality. These would be options that the user would have the ability to select when viewing the stream. Some other important stream settings are resolution and frame rate. Resolution determines the number of distinct pixels in each dimension that can be displayed. Frame rate determines the frequency at which frames in the video sequence are displayed. 1080p at 60 frames per second is the highest resolution and frame rate most streaming services support, so anything higher will simply be downscaled. And last but not least, the next important stream setting that OBS needs are the stream key and the stream service location. A stream key, also known as an authorization key, is a string of letters and numbers of varying length that uniquely identifies the stream. If you remember from before, the ingest server is the first place of the streaming service that the video feed reaches. Here, it is either matched to an existing account with the provided stream key or denied and returns an error. The stream service location simply tells the software which service to send your video feed to. OBS will then take all of these settings and encode the bits using any number of codecs such as H.264 and AAC. It will then contain the bits into a video container format such as FLV or MP4 and transport the containers using the RTMP protocol to the server designated earlier. For example, imagine the encoded bits in a stream as products in a customer's order, and in this case, the customer just happens to be ordering 2.5 million products every second, the same amount of bits encoded at 2500 kilobytes per second. The products can't be sent to the customer unless they are packaged properly, which in this analogy would be the container file format used to contain the encoded bits. The packaged products then need some form of transportation to make it to the customer. This is equitable to the RTMP protocol that transports the container files. In conclusion, because of computing and internet speeds nowadays, all of the processes discussed in this video happen so fast that it's really easy to forget just everything that's going on. Anyways, thanks so much for watching, and I hope this video has given you some insight and perhaps a newfound appreciation for all of the processes that go into producing a stream.